Okay, integrated 2, this is the probability review, which is really just more practice problems for you to do and then check your work against mine. So here's the first question. I'm going to go ahead and pause, work it out. I recommend that you pause and then check your work against mine. Okay, so here's the work on the first one. You'll notice that I went through and I set up the table or some sort of an area model just to try to organize it a little bit. And then I've got the probability of fish or a green vegetable. So we have a couple green vegetables in here we need to account for. But then when I go through and add these together because of the or situation, you have to make sure that you get rid of the sections that you double counted. So wherever my yellow highlight and my blue highlight came together. So you can see that I subtracted my double counting. So the 1/24ths off to the side, and it looks like the probability that we get here is a half. Okay, moving on. All right, so here's our next question. Pause, give it a shot, see how you did. Okay, so here's my work for the second one. I decided that this would be a good time to maybe draw a tree diagram out of this. And I know that 4 coins isn't an unreasonable tree, whereas with some other ones it was crazy. Also, I did choose to do this because I wanted us to take a look at the sample also, or like the different sampling space. So if you take a look at the end of each branch, that was a success. I went ahead and I wrote out the different combinations of heads and tails as well. Okay, moving on to the next one. Looks like we have another tree diagram. Okay, so if you take a look at this problem, you'll see that I went through and I put all of the probabilities at each one of the forks or each one of the opportunities for the rat to take a different path. And then I went through and I highlighted my paths, and you'll see that we have 1/8 for our first one because we've got that double half split that kind of happens where the blue and the purple is identified with the halves in there. And then we're going to take all of the different paths, take it to section A, and we're going to add up each one of those probabilities. That's going to give us 5/8. Okay, here we are with our next question. Give it a shot. Okay, so here's the work for the next one. So the probability of at least 2 tails is getting 2 as a success, or getting more than that. So possibly getting 3 tails out of 3 coin flips. I did go ahead and identify what the complement would have been if you chose to approach it that way. So all of the things that don't represent 2 or 3 tails, which would have been 0 or 1, and then you subtract that from 1 because it's 100%. But I did go through because it was only 3 coin flips, made a tree diagram, and figured out what that would have been. I also wrote down all of the different combinations as well, so you can see. And we've gotten 2/3 for this one. Okay, here we have another one. Give it a shot. Okay, so this question should look familiar. So I think I gave you something like this on a homework quiz not too long ago. So what I decided to do was I set up not an area diagram because I'm not doing multiplication of probabilities here. I'm just trying to figure out all of the different possibilities here if I roll 2 dice. So maybe a kind of a two-way table. I don't know. I think it's just an organizational tool, honestly. So I know that 1 through 6 is equally likely on each one of these. And then I went through and I used those because I'm finding the sum, I went through and added them all up. Now, if you keep this organizational tool organized, you're going to see this nice little growing pattern of your sums. So I could have filled them all in, but I know that once I go past these 4s, everything is going to be bigger in the table. So there's really no point. I also know that there is going to be 36 of these boxes because it is 6 by 6 dimension-wise, if you want to think about it that way. So I've got 36 total boxes, and out of those 36 boxes, it looks like 6 of them are going to give me a sum that is 4 or less. So I'm going to count up all of the green boxes. It's going to give me 6 out of 36, which I know can be simplified to 1 out of 6. Okay, let's take a look at the next one. Okay, so here's the solution to our next question. Figured a tree diagram probably made the most sense here, at least for me. And then found the ends of the branches that would give you the probability of a hit. So double check your work. hopefully you're doing well so far. Okay, moving on to the next question. Okay, so here's the solution to this one. Probably a bit more straightforward. I think we did these problems closer to the beginning of the chapter 3-7 combo. So double check your work. Again, hopefully you're being successful. We got a couple more slides and then we're done with this. Okay, here's our next one. A little bit more involved, a little bit more complicated. This is stuff that's going to predominantly cover things that we've done the most recently. As I was going through and completing this question, I noticed that the age range that I put on A needs to be adjusted because it doesn't really even fit in with the information that was given to you. So we're going to say under 20 years old. Okay, go ahead and keep working. Okay, so here are the solutions for this one. I did try to color code on part C so it would be a little bit easier so you knew that where I was looking to be able to fill in the conditional probability. So we know that soda A was chosen. That's important to note on part C. We're trying to figure out the probability of that specific age range, but we know that soda A has been chosen. So soda A is going to represent our total population size, if you want to think about it that way. Okay, and then here's our last question for this review. Okay, and here's my work for the last one. Again, a little bit more practice on the stuff that we've been doing a bit more recently.